Today we're learning about wormholes. Though they seem like magic, they're not. This is, though. Let's get started. Space. The final frontier. Sorry, wrong show. Let's try that again. Space is a crazy place filled with many crazy things, at least in theory. Scientists have mathematically predicted the existence of some of these things without actually being able to observe them. One of these structures is wormholes. Wormholes, sometimes called Einstein-Rosen bridges, are theoretical tunnels that join two places in space-time. In other words, they could join two places, two times, or both. They could even join different universes. The distance a wormhole covers may range from a few meters to a few light years. Wormholes arose from formulations of general relativity. The first type of wormholes formulated were Einstein-Rosen bridges. These wormholes resemble black holes until you get closer, which has made determining their existence difficult. Like black holes, Einstein-Rosen bridges suck objects in. However, instead of being stuck inside forever as they'd be in a black hole, objects sucked inside an Einstein-Rosen bridge would be spit back out of what's called a white hole on the other end. Unfortunately, this type of wormhole isn't traversable, since it had taken an infinite amount of time to cross and crimped shut in the middle. Very old string theory wormholes are more viable for cosmic travel. If string theory is an accurate representation of the universe, then several traversable wormholes could have formed milliseconds after the Big Bang. These wormholes don't have the same crimping issue as Einstein-Rosen bridges because they're propped open by cosmic streams. If humans were ever to create our own wormholes, they'd be constructed very similarly to these. The only problem is that man-made wormholes wouldn't have cosmic strings to keep gravity from closing them. Instead, our doorstop would be exotic matter, aka matter with special properties, such as a negative mass. Because exotic matter has a negative mass, it would exert a repulsive force. Scientists are still working on what exactly would qualify as exotic matter, though several possibilities, including space itself, have been examined. The vacuum of space is a promising candidate because it's constantly producing matter and antimatter, which we can manipulate to exist some of the behaviors of exotic matter. Perhaps one day we'll discover wormholes and how to use them. Or maybe they'll remain in our imagination as very scientific-sounding magic.